Hello, everybody. Welcome back. I hope you can hear me, right? So I think it's time to slightly prepare for our next invited speaker. So Zohar, if you are around, I will.
I'll share my.
Yes.
Okay.
Yeah, and I will introduce our second invited speaker for today. She is Zohar Eviatar. And she's professor of psychology at the University of Haifa in Israel, and her research is mainly focused in neuropsychology of language and cognitive neuropsychology, also bilingualism and literacy across different grading systems, as well as hemispheric specialization. And she will present us the talk entitled Reading in Different Languages, Early Differences and Late Similarities.
Okay, and I thought I'd chosen my talk. Are you seeing it? I'm not seeing it.
Yeah, you can make
How
wide screen. I mean,
wait, I'm going to stop this share and I'm going to start sharing again. Okay.
Yeah.
Why am I
Now
not
it's starting. Yeah, now it's visible. So if you now make a wider screen in the below part, there is an icon there in the right below.
Yeah. Oh. Okay.
In the presentation, just where is written note, one in the Zoom.
Why am I not seeing my own presentation? This worked yesterday. Just a second.
You should see your presentation, I think, right?
Wait, I'm going to stop sharing whatever it is I'm sharing. And then, I'm sorry. Let me see, I need to go to full screen, right?
Yep.
And then I need to share. I can share, right?
Yes, you actually did.
You're seeing my presentation?
Not right now.
Oh, see, I'm not seeing it either.
Now you are sharing.
Like,
now
you can see
visible.
it?
Now it's visible. Yeah.
Okay. All right. Okay. Good. Okay. So let me.
You can make now. Yes, exactly.
Now
There.
you see it? Okay. So everybody can see it?
Yep. I think.
Okay. So, all right. So I'm going to talk. So again, I also want to join everybody in thanking everybody for you guys for making this wonderful conference. It's really fascinating and wonderful. And I'm going to talk to you about reading. Everybody's been talking about speaking. I'm going to talk a little bit about reading. So my talk, why is it not? Okay. Whoops. My talk has three main parts. In the first part, I'm going to talk about reading in general and how it can happen with different writing systems. In the second part, I will show differences in the early stages of reading in readers of Arabic, Hebrew, and English, and present hypotheses about the source of these differences. In the third part, I will show eye movement data of skilled readers of Arabic and Hebrew reading both in L1 and in the L2 that reveal some universal aspects of reading. So first, let's talk a little bit about reading and writing. Now, we know that linguistic abilities in general are a result of both biological and cultural evolution. Okay, I'm having trouble here. And Corvallis has suggested that the catalyst for cultural development is spoken language as opposed to a gestural communication, and cites Bickerton, who said that for the first 1.95 million years after the emergence of erectus, almost nothing happened. The clunky stone tools became less clunky and slightly more diversified stone tools, and everything beyond that, from bone tools to supercomputers, happened in the last 1/40th of the period in question. And Corvallis has suggested that the origin or the source of this is the development of spoken language. And this is because of three different things. Basically, it can be used in the dark. So when we all gather in the cave after we've had our adventures, we can tell each other about what happened. We can start telling stories about ourselves, about our group. It leaves the hands free while so we can talk while we're doing things. And what's important to us here that it's amenable to being written. So the development or the addition of writing and reading to the human language faculty in the last 5,000 years has sped development even more. If you think about where we were technologically 5,000 years ago and where we are today, things are moving very, very fast. Cultural changes and demands on the individual have changed even more drastically over the last 400 years, to the extent that we have defined new disabilities, such as dyslexia and dysgraphia. 400 years ago, nobody was dyslexic because most people didn't know how to read. Now, literacy has become a minimal requirement in the modern world. And this is not an evolutionary timescale. So the question is, how can reading happen? And the reason reading can happen is because we know that the major characteristic of the brain is its plasticity and adaptability. The best example is the visual word form area, which is the region in the left fusiform gyrus that evolved to function in the early stages of object detection. It's the beginning of the what pathway in the dual root model of vision. And it has been accepted. Acceptation happens when something becomes adapted for detecting letters and words. That is, a visual region becomes specialized for linguistic function. And this is shown really beautifully in this paper by Dehane and Cohen, where this is the region. This is the region in the left hemisphere and the right hemisphere. And what we have here is the degree of activation when people are looking at written sentences. And we have people who are vary in how well they read. The green guys over here are really good readers, and the purple guys are illiterate, and everybody in between are on the scale between them. And what you can see is that the better reader you are, the more this region in the left hemisphere gets activated for written sentences. And what's very cool is that it also, at the same time, becomes less activated by objects, okay, by faces, by houses, by tools, and it just gets more activated as things look like letters or look like writing. So it's been shown that as people learn to read, this region becomes less activated by objects, it becomes more activated by letters, and it's connected, of course, to the homologous region in the right hemisphere and to language areas in other language areas in the left hemisphere. And we think that it's specialized to distinguish between small contrasted shapes. Many of the world's writing systems use line junctions from the same step. And this has been shown in an amazing study by Granger and his group, where they taught baboons to do lexical decision. Okay, so they could teach baboons to distinguish letter strings that are, for the baboons, obviously, are arbitrarily divided into those that have meaning in English and those that don't. And you can see that the baboons were pretty good at it. I mean, this is their accuracy, and this is their G prime. It's above 1. The baboons were actually quite good at learning this, which suggested to these researchers that the baboons were able to discriminate these visual objects, and that the primate brain might therefore be better prepared than previously thought to process printed words, hence facilitating the initial steps towards mastering one of the most complex of human skills, reading. So how do we model reading in humans? So obviously in humans, reading is comprised of visual and linguistic abilities, because the goal of writing is to represent speech in a visual way. So Granger's, this is the famous dual root model, okay? And Granger's results show that the baboons have the ability to perform the first part, the visual part of this process. But in general, when we talk about reading in people, we focus on the linguistic part of the root, that involves access to meaning, to orthography, and to phonology. And here we see them in the dual root model, and they're also the components of the famous triangle model of reading, which relates orthographic, phonological, and semantic knowledge in the word. And we're going to talk about the relationship between orthographic and phonological information. So there are varieties of ways that writing systems represent spoken language. I'm going to present you a taxonomy that was suggested by Peter Daniels, so the first one is obviously alphabets, where letters represent both consonants and vowels. And these kinds of writing systems differ in orthographic transparency. That is, how straightforwardly the sounds of the language are represented by these letters. Because in Spanish, for example, what you see is what you say, versus English, where you have to know that GH is sometimes silent, sometimes it's pronounced as an F, sometimes A is pronounced as an O, and sometimes it's an A, and so on. So English is a opaque language, and Spanish is a transparent language in terms of their writing system. They're both alphabetic writing systems. A second kind of writing system are abjad, where letters primarily represent consonants, and vowels are absent or sometimes are optional as diacritics. And both Arabic and Hebrew are examples of this kind of writing system. There are also abugidas. These are syllabic alphabets where letters represent syllables such as Devanagari and Cree and Kana and many more. And of course, there are the semantic phonetic scripts like Chinese and Hanja, where the symbols stand for concepts and syllables. So I'm going to talk only about alphabets and abjads because those are the writing systems that I know how to read, and those are the ones that I study. And we're going to explore the way in which characteristics of the writing system affect the reading system. For early processes, such as letter and word identification, we've concentrated on the organization or functional architecture of letter and word identification in the cerebral hemispheres. And for later processes, we examine reading fluency, that is the speed of reading aloud, and eye movements during silent text reading. So I'm going to talk a little bit about what do we know about hemispheric specialization for language. Everybody knows that the left hemisphere is dominant for language, but that the right hemisphere also participates. It seems that the degree of right hemisphere participation is due both to the characteristic of the language. So for example, there's more right hemisphere participation when people read Chinese than when they read English, and also to individual differences. There are some people have more right hemisphere participation within a same language. Some people have more right hemisphere participation, and some people have less. A lot of work has been done in the biological sources for the variations in this modal pattern. The pattern is much more consistent among right-handers than among left-handers, and there are some equivocal findings about sex differences which tend to interact with handedness, where it seems that right and left-handed women are more similar to each other than right and left-handed men. Left-handed men tend to be the odd people out. But I'm interested in the cultural effects on hemispheric involvement in reading, and these have to do with the effects of learning, with language experience. How many languages does the individual know and how they were learned? The structure of the language that the individual knows. And we also have other evidence showing that literacy in general affects the way we see the world. There's a whole bunch of a beautiful literature using the visual world paradigm, where we see that people who know how to read look at things differently than people who don't know how to read. So this is actually the same between the genetic envelope of the structure of the brain and the mental experiences of the individual, which is why I find it the most fascinating thing to look at. So, okay, so we've gotten to part 2, and we're going to talk about the early stages of reading, about letter and word identification in the cerebral hemispheres. The general paradigm is the divided visual field paradigm, which is based on the way the eyes are connected to the brain. So this person, we're looking at the brain from the top, and this person is looking straight at the center of the screen. And the way the eyes are connected to the brain is that everything that falls to the left of fixation goes first to the right hemisphere, and everything that falls to the right of fixation goes first to the left hemisphere. And when we look at performance, what we see are asymmetries. People perform differently when stimuli are presented to the left visual field or to the right visual field. And we assume that this performance asymmetry is indicating a hemispheric asymmetry, a functional asymmetry between the hemispheres. And we'll see later that we have good reason to assume that. A lot of my work is based on work of Eran Zaidel with the disconnected hemisphere, with the commiseratomized subject. And this is a beautiful study that he did with a LB who had two disconnected hemispheres. And what he did is he showed him this card, and he said, find two pictures that rhyme. And what you can see here, so we have a male, and we have male, and we have a semantic distractor. And what we see is that the left hemisphere, the disconnected left hemisphere, is 100%. This is really good. But the disconnected right hemisphere is pretty good too. You can see that it does significantly better than chance. It knows that the name of this object and the name of this object rhyme. Then he showed him this card, and he said, find a picture that rhymes with the word. And again, we see that the disconnected left hemisphere is doing 100%, but the disconnected right hemisphere is at chance. It cannot do this. It does not know that this word rhymes with the name of this object. So you could say, well, maybe this is because the right hemisphere doesn't know how to read. And so he did the third condition. And here he said, find the picture that goes with the word. So we have the object, and we have the name of it, and we have the word that names the object. And again, the left hemisphere is at 100%. But look, the right hemisphere is better than chance. So what does this mean? It means that the right hemisphere can access phonology from pictures because it knows that these two objects, the names of these two objects rhyme. And it can access meaning from orthography because it knows that this object is the meaning of this word. But it cannot access phonology from orthography. That's what it seems to not be able to do. So we asked, if the right hemisphere doesn't process the phonological aspects of orthography, how does it process diacritics in Hebrew? Now, Hebrew is an abjad, if you remember, and it can be written with vowels or without vowels. And this was a master's thesis of Eva Shmolka. And what she did is she showed people words that had diacritics and told them to ignore the diacritics. So these are all university students. They're skilled readers. They don't need the diacritics to read. Okay? This paradigm was first used by David Navoni Yosef Shimron. And what she did is she gave them lateralized presentation where they had to name the words, and they were told to ignore the diacritics. So we had a condition in which the diacritics were correct. This gives us the correct phonological pronunciation, sheled. We had a condition where the diacritics were wrong. It gives us a wrong phonological representation. It turns it into a non-word, but you can still read it if you ignore the diacritics. Then we had a figural condition where we actually had like little triangles and squares that actually don't have any phonological representation. So if you can just ignore it, you just read it without the diacritics. And she had an orthographic condition, which these two dots have the same phonological representation as these three dots. So it gives us also correct pronunciation, even though this is not the usual way that you give. This is not the correct diacritic. So what did she find? So first of all, remember, this is the left visual field. This is showing us right hemisphere processing, and this is the right visual field. And what we can see is we have a performance asymmetry for correctly pointed words. People read the words. These are reaction times to reading the words correctly. And we can see that when the words were presented directly to the left hemisphere in the right visual field, they were named faster than when they were presented directly to the right hemisphere, and that both hemispheres actually show a slowing due to the incorrect. When they saw the wrong diacritic, both of them were slowed down. Now, what happens with the grapheme? With the grapheme point, remember, this is the same phonological value as the correct, and what you can see is that both hemispheres perform in the same way as the correctly, and that's because most university students can't tell the difference between these two diacritics. But the important and interesting thing was what happened with the figural. With the figural, what we found is that the left hemisphere, because this has no phonological value, could ignore it, and they performed the same way as they did with the correctly pointed. With the right hemisphere, in their left visual field, they confused the hemisphere, it slowed performance down just as much as the incorrect condition. So it seems as if the right hemisphere treats diacritics as visual information, whereas the left hemisphere treats them as phonological information, and it also suggests that the disconnection between orthography and phonology in the right hemisphere that was shown by the commiseratomized patient reading English is also true for skilled, intact readers of Hebrew. So this suggests that this is a design characteristic of the brain, that the right hemisphere can get to semantics from phonology and from orthography to semantics, but not from orthography to phonology. So what happens with larger components? And now let's look at what happens with single letters. And we're looking at the visual characteristics of orthography and that affect how they are identified. And these data emerged from a study that actually looked at something else. It used a CBC identification task and focused on errors. So what we had is we had readers of native speakers of English, of Hebrew, and of Arabic. Each one did it in their native language. And these are just examples of the English and the Hebrew stimuli. And what they saw was a consonant, vowel, consonant either in the left visual field, in the right visual field, or in both visual fields. And what the task was to identify the letters making up the CBC. Now, because we were interested in errors, we titrated exposure durations so that the subjects would make 50% errors. So that gave us another bit of data. How long do we have to expose the stimuli for people to make 50% errors? And what we found was that for English, it's approximately 37 milliseconds. So if you show things for less than 40 milliseconds, native English speakers start to make their error rate rises to 50%. In Hebrew, it was twice as much. It was around 79 milliseconds, and that's because Hebrew letters are harder to distinguish than English letters. They're all, if anybody has seen Hebrew, they're basically variations on a square. What happens in Arabic? In Arabic, it got to 150 milliseconds. At 150 milliseconds, people are making errors, 50% errors on these stimuli to identify consonant, vowel, consonant, non-words. So it seems as if there's a specific difficulty to identify letters in Arabic as opposed to Hebrew and English. It's harder to recognize letters in Arabic than it is to recognize letters in Hebrew, which is harder than in English. So this led to a series of studies that I did with Rafik Ibrahim, where we looked at letter matching. We did a task, the task was letter matching by shape, and we had stimuli in both Hebrew and in Arabic. And we had, they had to make a decision based on the shape. And then we had all sorts of hypotheses about the different conditions, but the interesting results actually came from correct same responses. And I want to show them to you. We had two groups of subjects. We had Arabic speakers who are bilingual and they can read both Arabic and Hebrew. And we had Hebrew speakers who cannot read Arabic. They can read Hebrew but not Arabic. And what you can see in response time is that if you can read the language, you're showing a right visual field advantage. You're showing an advantage of the left hemisphere over the right hemisphere in in deciding that the two letters are identical. If you can't read the language, There's no difference between the two visual fields, and or essentially there's even a trend going the other way, because for these Hebrew speakers who can't read Arabic, seeing whether these two are the same was a somewhat difficult perceptual task. But the most amazing stuff happened with the accuracy. Let's look first at Hebrew speakers. What we can see is that both hemispheres are very accurate in telling if two letters are the same or not. And in Hebrew, they made very few errors, and because they're good, they're skilled readers. And in Arabic, they made more errors because they can't read Arabic, and again, it's a somewhat difficult task. What happens with Arabic speakers? Arabic speakers in Hebrew are exactly the same as Hebrew speakers. There's no difference. There's no effect of native language on these two when we compare performance on the Hebrew test. They're just as good. And we can see that, again, both hemispheres or both visual fields are pretty good. They're not making a lot of errors, and they're good. What happens in Arabic? Well, okay, that's to show that they're the same. If we're looking at the right visual field, that is the left hemisphere, there was no difference between how it performed in Arabic and how it performed in Hebrew. It was just as good. This is the right hemisphere of the same people, okay? But what happens in the left visual field? In the left visual field, Arabic speakers made as many errors as Hebrew speakers. That is, the right hemisphere of these participants was acting like the right hemisphere of people who can't read the language. Now, this is the same right hemisphere, which is very good at saying that two letters in Hebrew are the same. So that suggested to us to something, that there's something with the right hemisphere that's having trouble with Arabic letters. And we think that there's a particular characteristic of Arabic that's responsible for this. And that is because Arabic has 28 letters, but only has 17 shapes. So what happens is that you have different letters use the same basic shape, but they differ in the number and placement of dots. So this is a na, this is a ba, this is a fa, this is a ta, this is a ya, and this is a na. And you can see this is a ka and this is a fa. It's the same shape, only here there's two dots and here there's one dot, and so on. There's lots of other examples of this. So there's people who are visual neighbors, but represent completely different letters, completely different sounds. So we thought that maybe the relative insensitivity of the right hemisphere to local elements of objects hinders its ability to identify single letters if it's only based on whether there's one dot or two dots, whether it's a T or an N, okay? So in order to test this hypothesis, we used the Navon hierarchical letter paradigm in two conditions. In one condition, we use two letters that look very different. So we have a meme and a ta. They're very different from each other. And in the other condition, we use two very similar letters. We use the ta and a ba. They have basically the same shape, but a ta has two dots on top and ba has one dot on the bottom. Now, when we use two letters that look different, we got the same pattern that all the hundreds of thousands of experiments that have used this paradigm, and all sorts of with linguistic and non-linguistic stimuli and so on. Basically, what you see is that when we're asking people to discern the large letter, they're faster than when we're asking them to discern the small letters. So there's a global advantage, and that if the letter is made up of itself. So if we had a meme here that was made out of memes, you're faster than in this condition, for example, where we have a meme that's made out of ties. This is an inconsistent stimuli. These are the incongruent stimuli. And what you can see is that in all of the conditions, the consistent stimuli were faster than the inconsistent stimuli. And we also had a difference between visual fields where here in the global task, where the interference comes from the local level, it was larger in the right visual field than in the left visual field. And here in the local task, where interference is coming from the global level, interference was larger in the right visual field than in the left visual field. Okay, so this is what everybody else has found in lots of other languages. What happens when we use two similar letters? And what we find is that nothing. That is, in the global task, okay, the neither hemisphere can tell that they're two different letters. Okay, we have no effective consistency. Okay, and if we look at the local task, the right hemisphere and the left visual field, they still can't tell that one is a ta and one is a ba. The left hemisphere, in the right visual field, we do have a difference, an effective consistency. So this suggested to us that it's the visual characteristics of Arabic orthography that make it particularly difficult for the right hemisphere to discriminate between letters. And that may be the reason it was making as many errors as the right hemisphere of people who don't know how to read. So how far does the uninvolvement of the right hemisphere go? What are its effects? So we looked at word identification. So we had a lexical decision task with two kinds of presentation. The first one is the unilateral condition, where we show participants a stimulus in one visual field or the other, and they have to say whether it's a word or not. Okay, so only one hemisphere is seeing the stimulus. In the second condition, it's the bilateral condition. We present two words, one in each visual field, and we cue which one is supposed to, the subject is supposed to respond to. So here, so here, this the right hemisphere is supposed to respond to this word, but the left hemisphere also saw a word. And when we compare performance between these two, we can get an indication of the ability of each hemisphere to do the task by itself. Because what happens is that in the unilateral condition, the right hemisphere, the left hemisphere didn't get anything here. It is free to help the right hemisphere do the task. But in the bilateral condition, the left hemisphere has got its own stimulus. So it's doing something else, and the right hemisphere has to be on its own. And what we did is we did this task again with native speakers of English, Hebrew, and Arabic. This is our D prime. Okay, so this is accuracy. And what we see with English speakers is that performance overall is higher when only one hemisphere sees a stimulus, and that this is, of course, this is true in the left visual field. The right hemisphere does better when the left hemisphere can help it, but it's also true in the right visual field. The left hemisphere does better when the right hemisphere can help it. We also found the same pattern with Hebrew speakers. Okay, not unilateral is better than bilateral, and this is true for both, for performance in both visual fields. What happens with Arabic speakers? With Arabic speakers, we find this pattern in the left visual field, but not in the right visual field. The left hemisphere seems to be doing this task on its own. It doesn't get any help from the right hemisphere in the unilateral condition. You see, these are not different, whereas these are in these and we can we get strengthened in this hypothesis when we look at bias. Because if you look at the bias, what you see is that in English, two different things are happening in the bilateral and the unilateral condition. That is, it seems as if there are different processes happening here. These two tasks are different. This is true also in Hebrew. But in Arabic, what we get is exactly the same pattern of bias in our right visual field, irrespective of whether it was unilateral or bilateral. It seems as if the left hemisphere was on its own here, no matter what. So these data suggest that the right hemisphere doesn't participate in the identification of words in Arabic, whereas it does so in Hebrew and in English. This hypothesis is supported by a study that is led by Michal Ben Shachar, who I think has not published this yet, but this is an imaging study. And the task was, people were in the magnet, and the task was to press a button as soon as the plus in the middle of the screen changes color. Okay, that's the task. But the manipulation was that while people are looking at this, if there were Hebrew speakers, they saw either a word in Hebrew or a scrambler. And if they were Arabic speakers, they saw either a word in Arabic or a scrambler. And what we're looking at is in the area that's specialized to recognize words. Remember, we were talking about the beginning of the ventral pathway that's in both hemispheres and that gets specialized to recognize letters. So what happens? In Hebrew, what we see is that this is the degree of activation. What we see is that if we saw a word, there was more activation in this region than if there was a scramble. Okay? And whether it was in the left visual field or the right visual field. In Arabic, we see the same pattern. It's a little bit weaker in the left visual field, but still, if they saw a word, if there was a word there was more activation than there was if they saw a scramble. What happens in the right hemisphere? In Hebrew, you see the same pattern. There's still more activation if there was a word than if there was a scramble. And what's really nice here is, remember when we talked about the divided visual field paradigm, and we can see that when the word was presented in the right visual field, there's more activation in the left hemisphere, and when the word was presented in the left visual field, there's more activation in the right hemisphere. So this sort of strengthens our belief in our ability to use the divided visual field paradigm. What happens in Arabic in the right hemisphere? Absolutely nothing. There is no more activation for words than for scrambles. Okay? So to summarize, in the early stages, what we have is evidence that the visual characteristics of the orthography impact the lateralization of the ventral root for the reception of language. Okay, so the kind of orthography that you have, remember we saw the pattern that Dehaene and Cohen showed us, and now we're seeing that the kind of orthography has an effect. And both behavioral and imaging data suggest that there's a specific right hemisphere deficit in the identification of letters and words in Arabic, whereas there's no such deficit in Hebrew and English. For Hebrew and English, we have both behavioral and imaging data suggesting that the right hemisphere is involved in the identification of letters and words. Okay, so now let's look at real text. We've just been looking at letters and words. Now we're looking at reading real text. And I'm going to tell you about two studies of text reading in L1 and L2 by skilled readers. The first study examined reading speed of text in Arabic and Hebrew. And the second study examined eye movements during text reading in Arabic speakers in Arabic, Hebrew, and English, and in Hebrew speakers in Hebrew and English. So why is reading speed interesting? Recall that writing represents spoken language. Therefore, oral reading, or the speed which readers can decode the graphings on the page to speech, can tell us the efficiency with which they transfer this visual information into phonological information. In the case of Arabic, this becomes especially interesting because the spoken language is different from the written language. Arabic is the classic example of diglossia. Okay, spoken Arabic is the native language of all Arabic speakers, and it's a variety of regional dialects. Until very recently, it was considered invalid to write it. Okay, this has been changed. It was not okay to write spoken Arabic. This has been changing in the context of computer-mediated communication because young people have started writing spoken Arabic in their chat and on Facebook and when they SMS using their smartphone. But this is still frowned upon by the establishment. Older people, it's a very generational phenomenon. Young people can feel free to write spoken Arabic and older people do not. Modern Standard Arabic or Literary Arabic is uniform across the Arab world, and this is the language of literacy. Children learn it while learning to read. Now, thus, readers of Arabic are reading a language which they usually do not speak or sometimes never speak. They're quite shy about speaking Modern Standard Arabic. We have shown that 5- and 6-year-old Arabic speakers who are exposed to MSA, to literary Arabic, they start being exposed to it in kindergarten and first grade in order to prepare them to learn to read. And we have shown that they behave like bilinguals. That is, the cognitive system of these children reacts to spoken Arabic and modern standard Arabic as if they're two different languages. They're different enough from each other that the cognitive system treats them like two different languages. And Eran Zaidel has shown in lots of different studies that reading acquisition is affected by the characteristics of the spoken dialect. So if a letter represents a sound that is included in your dialect, you learn it much more easily than if it represents a sound that's not included in your spoken dialect. And the dialect and the spoken Arabic and modern standard Arabic differ phonologically, and the spoken dialects differ from each other phonologically. So when we look at how Arabic speakers read out loud, this can be informative about the relationship between spoken and written language. And this study was done in collaboration with the National Institute for Testing and Evaluation, which is the source of college entrance examinations, what's called the psychometric exam in Israel. And you can understand why it's important that we look at the efficiency of reading in these different writings. So what we had was native speakers of Arabic and native speakers of Hebrew who read texts of varying complexity. All of them were university students, so all of them had passed the psychometric exam. And Arabic speakers read texts in both Arabic and in Hebrew. But beforehand, we compared them on letter identification and single word and non-word reading. So in the trail-making task is where you see letters and numbers spread randomly on a piece of paper, and you have to connect them with the line alternately in order. So it's like 1A, 2B, and so on. And Hebrew speakers were faster, but Arabic speakers were the same, showed no difference between L1 and L2. They did the test just as fast in Hebrew as they did in Arabic. We also gave them the rapid access naming task, the RAN, where you see a matrix of 50 letters and you have to name the letters as fast as possible. And Hebrew speakers were faster, and Arabic speakers again showed no difference between naming letters in Arabic and naming letters in Hebrew. In reading single non-words, there was no difference between any of the groups. They were all just as fast. And in reading single words, Hebrew speakers were faster, but Arabic speakers again showed no difference between reading single words in Arabic and single words in Hebrew. Okay, what happens with the text? So we had two kinds of text. We had the psychometric exam test, which was complex, and we also had the PISA test, the text, which was created for 15-year-olds. So it was simple for our university students. And what we see is that we had them read silently and we had them read out loud. These are the complex texts, and this is the easy text. And what we see is that in the easier text, there was no significant difference between the groups, but in the complex text, both silent and reading aloud, Hebrew speakers read Hebrew faster than Arabic readers read Arabic. Okay? What happens in Hebrew? Now recall that Arabic speakers were just as fast at recognizing letters and words in Hebrew as in Arabic, but obviously when Hebrew speakers are reading in L1, they're faster than Arabic speakers reading in L2. Okay? So here we see an effect of language status, that Arabic speakers are reading in Hebrew, even though they're all very proficient bilinguals. They're still slower than people who are reading their native language. And when we compared Arabic speakers reading in Hebrew and in Arabic, what we found was that they're still reading Arabic faster than they read Hebrew. Okay? So even though they read single words and recognize letters just as fast in Arabic as in Hebrew, when they're reading a complex text, they're faster in Arabic than in L1 than in L2. So although native speakers recognize letters and words with the same speed in L1 and L2. And maybe we thought maybe this is because MSA is not their native spoken language. Recall that modern Standard Arabic is different from spoken Arabic, but they still read complex text faster in MSA than in Hebrew. And we thought that maybe this is because MSA is the language they learn to read first and they're more facile with. Although all the students are students at a Hebrew university where coursework takes place in Hebrew. So one possibility is that modern Standard Arabic is their native visual language because it's the language that they learn to read first. And there are several people from my university who have suggested that Arabic speakers have MSA as a L1, as a visual L1, and spoken language is an auditory L1. I don't know if I accept that yet. Okay, now I'm going to talk to you about the eye tracking study. This was a PhD dissertation of Hendla Hood, and it was carried out together with Dr. Hamutal Kreiner, which some of you know. In eye tracking, there's text, and there's lots of measures. I'm going to talk to you about, we measure how long people stay on certain words. There's first fixation duration. Whoops. Why am I seeing this? And so this is how long the person's eyes stayed on this word. And dwell time is all fixations of the word. So you can see, for example, that for truth, there was a regression. The eyes went back to the word truth, and so dwell time is the sum of this fixation and this fixation. And we also looked at skips. People's eyes skip words. Okay. Okay. This is the design. What we had was native Arabic and native Hebrew speakers who read texts from health sites on the internet. There's these texts that you get from the HMOs, which tell you how much you should sleep and whether you should use a dishwasher and all sorts of things like that. The Arabic speakers read text in Arabic, in Hebrew, and in English, and the Hebrew speakers read in Hebrew and in English. And you can see that there are lots of different comparisons that you can make. I'm only going to tell you about some of them. So the participants were 20 native Arabic speakers and 20 native Hebrew speakers. And the materials were taken from online healthcare websites, 3 in Arabic, 3 in Hebrew, and 3 in English. And the interest area was set per word. And here's an example of, so there were usually 5 different screens for each text. So, and you can see that what we have are different writing systems, different orthographies. And we also have differences in morphology because Hebrew and Arabic are sister languages. They're both Semitic languages, and they have a non-concatenative morphology where roots are put into word forms, whereas English has a concatenated morphology. So there are differences in the structure of the languages, and in addition, there are differences in the language status. For some people, Arabic is L1, for some people, Hebrew is L1, and for all of our subjects, English was L2. Okay, so just looking at the text, what you can see is what we have here is we have word length, we have word frequency here, and you can see that in all of the text, we divided the words into content and function words. That function words tend to be shorter in Arabic, in Hebrew, and in English, and content words tend to be longer. We took out all words that were longer than 8 letters, just so that we could compare things. Okay, so the text, in English, we used frequency sites. Frequency overall in English is higher than Hebrew and Arabic. Okay, so let's look at each language group reading in L1. And we had self-report measures of how well they read and how proficient they are and how much they're exposed to the language and so on. So now we're going to look at Arabic speakers reading in Arabic and Hebrew speakers reading in Hebrew. And you can see that they rate themselves pretty similarly in terms of proficiency. However, Arabic speakers are less exposed to reading in Arabic than Hebrew readers are to Hebrew, because Hebrew readers, remember, are reading the language that they speak. Arabic speakers read less in MSA. In general, we can see that Hebrew readers, 93% of the time they're reading in Hebrew. Arabic speakers are only reading around half the time. And what's most interesting is that Hebrew speakers are reading faster. Again, Hebrew speakers read words faster in Hebrew than Arabic speakers read words in Arabic. Okay? So let's look at their eye movements. And what we can, just remember our dependent variables are first fast skipping, how much do they skip, first fixation duration, and dwell time. And we analyze these with LME analysis, with language, word frequency, word length, and part of speech as our 6 factors. These are the benchmark factors that affect eye movements in English, for example, and in other languages. And we had our random factors were separate from either. So just let's look at the descriptive statistics. What we can see, the data for Arabic and Hebrew are from our study, and the data for English are taken from Rayner. And what you can see is that in terms of average fixation duration, Hebrew speakers are a little bit faster than in English, and Arabic speakers fall right in the middle. But fixation duration in Arabic was longer in our study than it was in Hebrew. Okay? If we also look at fixations per 100 words, what we can see is that Hebrew speakers now fall towards the top of the English range, whereas Arabic speakers fall out of it. And I think that this is probably due to the morphology. We call that Hebrew has a more dense and complex morphology, and so people have to fixate more on words, whereas in English you can, and in both Hebrew and Arabic, there are many bound morphemes, so most function words are morphemes, whereas in English people per 100 words skip. And we can see here that in general, function words, content words were skipped more in Arabic and Hebrew than in English, and function words were skipped around the same. So these are the characteristics of the data. They're not that different. And now let's look at skipping rate. And what we have is we've got an interaction of language by part of speech. And this is the Arabic readers, this is the Hebrew readers. And what we can see here is that, what we can see here is that for both languages, there's more skipping for function words than for content words. But the difference in the interaction occurs because the difference is larger in Arabic than in Hebrew. That is, content words in Arabic were skipped the least amount, whereas content words in Hebrew were skipped more than content words in Arabic. There was no difference between the two languages in skipping rate of function words. If we look, we also got a language by word length interaction, and what we see is that on skipping rate, and what we see is that for both languages, the longer the word, the less probable it is that it's going to be skipped. Okay, shorter words are skipped more than longer words, but that the slope is higher for Hebrew speakers than it is for Arabic, or for the Hebrew language than for the Arabic. So there's less skipping on content words in Arabic, and the effect of word length is stronger in Hebrew than in Arabic. What happens with first fixation, duration, and dwell time? And what we see is basically the same pattern that we saw before in skipping, only the other way. That is, for function words, let's put it this way. In Hebrew, first fixation duration was approximately the same for function and content words. But for Arabic, the content words were fixated for much longer, significantly longer than in Hebrew, and significantly longer than function words. And if we look at dwell time, we see this the pattern survive. Looking at other fixations, at the rest of the fixations, content words in Arabic are fixated for longer than content words in Hebrew, and there's no difference between the languages in function words. Okay? So one of the hypotheses that we had is that this is an effect of the diglossia. Recall that Arabic speakers are reading a language they don't speak. And so it's more probable that they are less familiar with the words, with the content words that they're reading than Hebrew speakers who are reading a language that they do speak. So they don't have to spend as much time to recognize it. What happens when they're reading in L2? So I'm going to tell you about several comparisons. One is about Arabic speakers reading in Arabic and Hebrew. So what do their eye movements look like when they're reading in L1 versus when they're reading in L2? And the question here is, how much of the characteristics of eye movement during skilled reading is dictated by the skill of the reader and how much by the structure of the language? Because recall that we had differences between the patterns shown by Arabic speakers in Arabic and Hebrew speakers in Hebrew. How much of the patterns in Hebrew is because the people who were reading it were extremely skilled. So Hebrew is read faster as L1 than Arabic is L1. What happens when it's L2? And in L1, content words in Arabic have longer first fixation durations and dwell time and lower skipping rates than Hebrew when it's L1. And as we saw, word length had a stronger effect in Hebrew than in Arabic. Then I'm going to show you a comparison of both groups in English. Does having a different L1 have effects on reading in an L2? So if you're an Arabic reader, a native Arabic reader, or a native Hebrew reader, are you going to look different when you're reading English? And the last one is looking at L2s with different morphological structure. So we're going to compare Arabic speakers reading in Hebrew versus reading in English. Okay, so what we're looking at now are Arabic speakers reading it in L1 versus in L2. And what you can see is that they rate themselves as a little lower in proficiency, though they're still pretty high. They're exposed to Arabic, to modern standard Arabic, more than they are to Hebrew. In their self-report, they read modern standard Arabic more than they read Hebrew. But most amazingly, look, they're still reading words in Hebrew faster than they're reading words in Arabic. So what do their eye movements look like? And if we look at first fixation duration, what we see, this is Arabic and this is Hebrew. So these are Arabic speakers, and this is their L1 and this is their L2. And what we find is a language by part of speech interaction. They're reading Arabic faster than they're reading Hebrew. Okay, we have a main effect of language with L1 being read faster than L2. But what's amazing is that the difference between content and function words is still apparent in Arabic where it's not apparent in Hebrew. Okay, so what happens is the characteristics of a larger difference between content and function words in Arabic survives even when it's a different language status. Okay, so in Hebrew, these are Arabic speakers reading in Hebrew. This is their second language, and they're not taking longer on content words, whereas in Arabic, they still are. So now let's look at Arabic speakers. We're continuing this, and let's look at dwell time. And what we find is the dwell time is, this is Arabic, this is Hebrew. Dwell time is shorter in their L1, which makes sense, but the difference in slope is still apparent where word length still has a stronger effect in Hebrew than it does in Arabic. So although dwell time is shorter in L1 than in L2, we see a replication of the effective language, okay? Word length has a stronger effect in Hebrew than it does in Arabic. And if we look at skipping rate, we see the same thing. So Hebrew is skipped less. This is skipping rate. And you skip less if you're reading Hebrew than if you're reading Arabic. But again, the slope for Hebrew in terms of word length is steeper than it is for Arabic. So the characteristic of the language where word length has a stronger effect in Hebrew than in Arabic is replicated even when it's in L2, which suggests that this has to do with that this is a property of the writing system, not necessarily of the reader who's reading it. And the most evident effect of diglossia, this is the most amazing result, is skipping rate. This is Arabic, and this is Hebrew. And native Arabic speakers skip less in Arabic than they do in Hebrew. Even though it's their second language, they're still skipping more words in Hebrew than they are in Arabic. So this is definitely an effect of the diglossia. We think that's how we interpret it. The next, oops, I went the wrong way. Sorry. The next one is what happens when they're reading English. So now we're comparing Arabic speakers with Hebrew speakers. And you can see that Arabic speakers rate themselves as a little bit more proficient than Hebrew speakers reading English. They say they read English more than Hebrew speakers read English. They're a lot more. And you can see that they read English, the two groups read English at approximately the same speed. And what we found was no differences between the groups, and Bayes' factor actually supports the null hypothesis. They really are the same. The results showed more frequent words had shorter fixations, which is one of the benchmarks of the eye movement literature. In skipping rate, there was no effective native language. Shorter words were skipped more often, as shown by English L1 readers. And in dwell time, as for English speakers, higher word frequencies associated with shorter dwell time. But this decrease was larger for Hebrew speakers and Arabic speakers. We don't know why. But in general, there were no differences. It doesn't matter if your native language is Arabic or Hebrew, you read English actually a lot like L1 readers read English, probably slower. So now the interesting comparison is between Arabic speakers and Hebrew versus English. This is interesting because Hebrew and Arabic are much more similar to each other. They're both read from right to left. They have similar morphological structure, and both are abjads, whereas English is an alphabet. So now we're looking at Arabic speakers reading in Hebrew versus reading in English. And we see that they rate themselves pretty much the same. They also have approximately the same exposure to the two languages. They read a little bit more in English than they do in Hebrew. But you can see here that they're reading Hebrew faster than they read English. Okay? And what we found was that Hebrew was read with shorter fixation durations than English. Word frequency was associated with shorter durations as usual. And there was no main effect of language for skipping rate. They were the same. But we did find an interaction of language by word length. And what we see is that, again, word length has a stronger effect in Hebrew than it does in English. This is what we saw before. And this was also true. We also found a language by frequency where the more frequent the word, the more probable it was that it would get skipped. And this was true in English, but less so in Hebrew. For dwell time, we only found main effects that everybody finds English words had longer dwell times than Hebrew. Longer words had longer dwell time, and less frequent words had longer dwell time. So to summarize, Arabic as the first language is read more slowly than Hebrew as a first language. And this is shown in reading speed measures and in longer and more fixations on content words. And we think our interpretation is that this is the effect of the diglossia, the less familiarity of Arabic speakers with modern standard Arabic than Hebrew speakers with Hebrew. Both languages reveal the benchmark findings shown for alphabetic languages for the effects of word frequency, of word length, and part of speech. And this is what I meant when I said that there are universal aspects of reading. And although Arabic speakers read Arabic faster than Hebrew, they still have longer fixations and longer skipping rates in content and function words in Arabic, but not in Hebrew. That is, they show this effect, this difference between function and content words in Arabic, but they don't show it in Hebrew, even though they're reading Arabic faster. And having Arabic or Hebrew as a first language did not affect eye movements while reading English. And in general, Arabic speakers have shorter fixation durations when reading L2 Hebrew than L2 English. So let's try to tie this all up. I said a lot of things. There are effects of the visual aspects of letters on the early stages of reading. And these suggest that there's less right hemisphere involvement in Arabic than in Hebrew and in English. Okay, I showed that both letters and words. But eye movements reveal the same basic patterns as shown previously for other languages. Effects of part of speech, of word length, and of word frequency, together with the effects of diglossia in Arabic. So the differences in patterns between Hebrew and Arabic survive the changes in language status. So even if Hebrew is being read as a second language, it still shows specific characteristics that distinguish it from Arabic. So the obvious next step, of course, is to link up the early differences and late similarities by imaging while Arabic speakers read in L1 in Hebrew and in English compared to Hebrew speakers. So the prediction would be that in general, there's probably more right hemisphere involvement when bilinguals read in L2 in general. But when reading in L1, there should be, if I'm right, there should be less right hemisphere involvement in Arabic than in Hebrew. All I need is the funding to do this. And if anybody has any suggestions, I'm open to suggestions here to do this, to look at the differences between the initial stages of reading where we're just identifying letters and words and where we're reading complex text. How do things change and how does the balance of power change between the hemispheres? And that's it. Thank you.
Thank you very much, Zohar, for such an interesting talk. We have time now for questions. Please, you can type in the chat and I will read for Zohar, or you can raise your hand. Well, before people is maybe thinking about possible questions, maybe I can ask something about this late data that you present in for eye tracking. If I understand correctly, we can see the different patterns between L1 or L2. Even this survive the language status. Do you have something maybe I missed about the transfer of these patterns to second language, and particularly if you have run something or you have some data about how this affect novel word learning in visual domain. So when we confront the reader with novel words to learn from. Yeah. So
okay.
How this affects what is the prediction, and if you have some data about how the patterns in L1, particularly for Arabic and Hebrew, but maybe other languages, for example, logographic versus alphabetic systems, how the patterns, if there is going to be a transfer, and how this is going to affect particularly the learning.
Right. So you know, when we did the experiment with the reading speed, we made non-words in Arabic and in Hebrew, And the Arabic speakers read them at the same speed. But Hebrew speakers read the words in Hebrew. Hebrew speakers did it only in Hebrew. And they were faster. They were faster than Arabic speakers in L1 and faster than Arabic speakers in Hebrew. So, and I think our data about the letters show, because when you're reading a non-word or a novel word, as you call it, all you have is the orthography phonology relation. You don't have semantics to help you. You can't recognize and say, oh, this is what the word is, right? So it's only orthography phonology. And it seems as if their Arabic is harder than Hebrew or English. The relationship is more complex and it's harder. And you can see that also in learning acquisition, in reading acquisition. In Hebrew, for example, Hebrew with diacritics is a very transparent script. Kids by the middle of the year are reading. They can read. Mm-hmm. And in Arabic, it takes them even till the middle or end of second grade to learn all the letters. Because I didn't tell you this, but Arabic letters look different if they're in the beginning of the word, if they're in the middle of the word, or if they're in the end of the word, if they come after a word, a letter that connects or doesn't connect. It's the orthography in general, the writing system is so much more complex that it takes almost to the end of second grade to just learn all the letters. And so I think that difficulty translates higher and higher, just goes with them. I mean, if they're reading, and that's why you don't see it in text, because in text there's no, you're going for the semantics, and to go for the semantics, to go for the meaning from the orthography and the phonology, they're very good at that. They're very, very practiced at that. But when you show people non-words, all they can do is do the decoding from graphic to phoneme. Mm-hmm. And so, and if that relationship is hard, then it's hard.
In this sense, I guess the semantics is could help very much this disadvantage. Great, thank you very much. We have some questions in the chat. I will read. Lori Feldman said, very interesting program of work. Can you elaborate on what assurance you have that comprehension in Hebrew and Arabic sorry, is comparable when you compare content and function words in each?
Well, what we did is we compared. Well, you can't really do that because recall that Arabic speakers are reading a language they don't speak. So it's a language in which they learn to read. It's a language in which they read all the text in school. Okay, this is the language in which the newspapers are written and so on. So, but it's not a language that's spoken. And so it's not as familiar to them as Hebrew speakers who see a word which they use, which they read and they speak all the time. So you can't really compare them. We did have comprehension questions at the end of each text to make sure that people read them to understand, and everybody understood. I mean, they were pretty simple texts in the eye movement. And also in the reading speed experiment, we also had comprehension questions, and everybody answered them correctly. I mean, these were university students who had passed this exam, so they could do this. So there were, let's put it this way, they all passed the lower bar. We don't know about the higher bar.
We have another question from Olga Parcina. Thank you so much. Would you be so kind to repeat whether you found differences in the early measures, skipping and first fixation duration, in reading in L2 English and L2 Hebrew? Was there an effect of script differences, for example, difficulties with grapheme to phoneme decoding? And was it smaller between Arabic and Hebrew and Arabic and English? Thank you.
Yeah, so in the last comparison, we compared Arabic speakers reading Hebrew and reading English, both of which are second languages to them, and they were faster in Hebrew. They were always faster in Hebrew. And you can think maybe because they're, maybe not all of them said that they read Hebrew better than English, but they are in a Hebrew-speaking university, and they have to read a lot of Hebrew. And also, Hebrew is closer to Arabic. It's a sister language, so morphologically, it's closer, and so on. So, and there are many cognates between the two languages. So there, you can make up a lot of stories about why they read Hebrew faster, and they recognize the letters and the words faster in Hebrew than in English.
Any more questions? Maybe some hands raised. Lorraine Obler is it possible that the findings for L1 Arabic in Israel may not be comparable for those reading L1 Arabic in a bilingual culture where the L2 is not a Semitic language with many cognates between the two languages, for example, Arabic L1 and French L2? That is, would learning reading Hebrew provide more interference in Israel's Arabic speakers than in a country where another Semitic language is not the L2? Great talk. Thank you.
Well, thanks, Lorraine. Actually, that would be a great study to do. What is the effect of, like, it would be, the obvious thing would be to do the experiment in Lebanon or in Jordan, right, where they have French or English as the L2, and where they go to school. In Jordan, for example, university is in English, so it would be a great experiment to do. I don't know if I think that it's more interference. It might be more facilitated. I don't know. I mean, that's the reason to do the experiment, right? We can tell the story either way.
Okay, any more questions? Yeah, we have one more comment. Hamut Al-Krainer. Following Sorach's talk yesterday about the right control group for attrition research, I'd like to hear what Zohar and others think about bilingual minorities, not immigrants, as the comparison group. Do they allow us to get better understanding of the brain-environment relationship in attrition and dominant shift?
That's a great question. We actually looked at that from another perspective in a study that we did about accents, about foreign accents. That's why when Monica suggested what would be the factors, I wrote empathy, because we found that empathy has an effect on whether you get the on whether you can get the L2 accent, even if you're a late bilingual. It's related if you're an immigrant, but if you're a minority, it's not related. What we did is we compared Russian immigrants and Arabic students speaking Hebrew, and we gave them an empathy test. And what we found is that and then we had people rate their accent. And for Russian immigrants, there was a positive correlation between how empathic they are and how light their accent was. That is, the lighter your accent, the more empathic you are, the lighter your accent. But for Arabic speakers, there was no relationship. And when we talked to them afterwards, they said, well, yeah, I mean, I don't want to sound like the Jew. My accent is part of my identity, okay? Whereas Russian immigrants who come to Israel want to merge with the majority, and so so very often they want to get rid of their accent. So there's lots of different things that will affect how much, and I think that using language minority is an interesting, but it makes things more complicated because the motivation aspect of it. Because immigrants have, you sort of assume that immigrants have a motivation to learn the L2 and to become L2 speakers, whereas people who are in minority learn the L2 because they have no choice. They would probably rather not, but they still, but they have no choice, but they have to learn it in order to survive in the society. So it's a different, they're coming from different places. And so the motivation would be, that would be a good way to test the effective motivation.
Okay, thank you very much, Zohar. I think we should stop here to have a short break before our last talk, if that is okay. So thank you again very much for such interesting talk about reading. Was very, very nice. And let's have now short break, maybe starting, if it's okay, 5 minutes past from o'clock. So I will come back around in 10 minutes, let's say. Okay. So see you again in 10 minutes. Thank you.